So this time last year here at Deep Tech Momentum, I moderated the panel on space, and Daniel Metzler at ESAR Aerospace said something I couldn't stop thinking about. He said, if an ICBM were heading toward Europe right now, we would be relying on the US to tell us about it. We don't have the capacity to detect it, much less do anything about it. Well, a lot has happened in the last 12 months, and there's been a lot of urgency to build its own sovereign capabilities here in Europe. Everything we took for granted is up for grabs. Access to critical resources, whether the image we're looking at is real or manufactured, and long-standing strategic alliances. I mean, 18 months ago, how high was NATO's future on your risk register? And at the same time, we're seeing a convergence of accelerating trends. We have the generative AI capability, infrastructure resilience, and this urgent build-out of sovereign defense capability. And thanks to that convergence, Earth observation has crossed a threshold. Because for years, VCs thought of EO as this commoditized market with a capped TAM. And then the world order shifted, and Earth observation went from being an uninteresting niche to genuinely strategic. Last year alone, it attracted €2 billion in private funding. As one analyst put it, defense has become not just the anchor for this industry, it's the entire boat. And then, of course, the war in Iran just put the nail in that. So what we're about to hear in this session is how 6 of the key European players are responding in this moment. Each of them owns a link in the chain, from the radar constellation that sees through clouds and darkness to the rocket that's essential to get it there. And together, they're going to show us this blueprint of how Europe goes from dependent to capable. And the question for me is, running through all 6, is how close is Europe to owning this picture independently? So one of the glaring bottlenecks is launch. Launch is the one link in this value chain that Europe still depends on others to provide. And so our first speaker, Joseph Fleischmann, CTO at ESAR Aerospace, is one of 2 people you'll be hearing from today, racing to change that. He's going to share with us how ESAR is solving this bottleneck with a scalable launch production. Welcome to the stage, Joseph Fleischmann. You have the clicker.
Hello, everybody. I'm seeing an ISI presentation in front of me. Now it's an ESAR Aerospace presentation. Very good. Thank you so much for the introduction. So, as we said, we are the first step in the space industry when it comes to space industry. But in general, we're not flying rockets for fun. Well, of course, also for fun, but then there is a huge business behind now. When I was a small child, launching rockets in our home farm, I was doing it for fun. I had no understanding what the space actually needed for, until I was in my 20s and actually studied where is space hidden. Of course, we know GPS. Of course, we know communication satellites. But nowadays, we depend so much more on everything that is in space. In the Ukraine war, the Iran war was mentioned. It wouldn't work out without space. Logistics and supply chain management today, no way without systems in space. We're looking in the near future, and we're seeing data centers, large power stations in space that harvest solar power. All of that is coming, and the market is extremely booming. And now comes something that is honestly a bit embarrassing for Europe. So we see here, in this whole decade, we see the US, we see the rest of the world, which is largely Russia, mostly China also, a bit of India, and then we see a column that hardly exists, that shows Europe. That's the amount of launches that were conducted out of each of these continents. So really a shame, and that really blocks Europe from building up or from even participating in this future growth market, which is honestly massive. We see that in the upcoming IPO of SpaceX, one of the most valuable companies ever, to be honest. So we need to catch up. That's quite clear, and it's quite a task. But how is ESA Aerospace trying to solve that issue? First of all, we need to consider speed and scalability. Speed and development, which is always a bit of my personal matter. It took ESA Aerospace roughly 4 years between having 10 million euros on the bank account and the first launch last year. We were not just doing that exclusively. We were also investing a lot of money into building what we call the machine behind the machine. So this is not just about making one rocket in a garage. This is really about scaling up launch vehicles so that we can really compete with the numbers that we see in the US, that we see in China and other countries. For that, actually, we first of all designed this rocket to be mass manufactured, something that hadn't been done before in Europe. And we have actually in parallel just built a 40,000 square meter production facility for launch vehicles that will open soon just outside of Munich. So where are we at the moment, and how do we wanna get closer to closing this gap? Last year, after 7 years of company history and 4 years of intense development, so all of you that have founded startups know in the beginning it's a bit hard. So you don't really get much money, and you have to create stuff from it. Nevertheless, we went to a first launch in March 2025. We built a fully scalable, fully vertically integrated production in Munich. So vertically integrated means every step that is unique to ESA Aerospace launch vehicle can be both manufactured as well as tested by us, and we own 100% of the IP. That means in case we see something going wrong in launch vehicles, and things do go wrong in launch vehicles, unfortunately, we all know that, we can learn from it as quickly as possible and come back to the pad, to the launch pad as quickly as possible, or to the test or whatever it may be. And once we have conducted our launch, really our next step is to really scale up. So this facility that you see here is dimensioned to produce the launch vehicle 40 times per year, 40. So we need a few more companies to keep up with the US, but at least ESA Aerospace is going to help Europe in that sense quite a bit. So that was it actually, our first launch from last year. Thank you very much.
Joseph.
Are there any questions?
No.
No questions. Okay.
So. Thank you, Joseph. Next, 70 satellites in orbit. ICEYE is the world leader in sovereign intelligence in space, with contracts with Germany, Poland, Finland, Greece, and US. We'll have Philipp Herkelmann, CEO of the German operations, here to share how ICEYE has cracked the commercial model that can scale globally. Welcome, Philipp, to the stage.
Apologies, that's the end of the presentation. Hi, my name is Philipp. I'm the CEO for ICEYE Germany. Thank you for the introduction and thank you for having me. I looked at deep tech in Europe from various angles. I looked at it from the Silicon Valley when I was like a program lead for Google X. I looked at it as an investor at Entrepreneur First, and now also as from policy side when we started EU Inc. So deep tech in Europe has a hard time to scale, so I'm very happy to present shortly a venture that has scaled globally from Europe. We talk about ICEYE. When you think about satellites, most people think about telescopes, optical, looking at Earth. The problem is that when you look at Earth, 70% is always covered in clouds, 50% is always dark due to night. So there's not much signal you can extract. Synthetic aperture radar works through clouds, through darkness, through smoke, and through volcano ash by sending an electronic signal to Earth, catching the reflection, and then creating an image out of Earth. And as the satellite is flying over Earth, it can cover a wide range, up to 200 times 300 square meters, and also a high resolution, 25 centimeters. So that means you can see the car, but you cannot see the driver yet. The technology itself is quite old. I think it's 80 years old. But the reality was, back in the days, when Pekka Laurila and Rafał Modrzewski started out building this new SAR satellite in their dorm in Alto Helsinki in 2014, a SAR satellite cost around €500 million, weighed around 2 tons, and there were only 4 states in the world that were able to afford this kind of satellites. So they set out to shrink the sensor, shrink the satellite. For that, they almost entirely vertically integrated the building of the satellite and made it smaller, made it cost-effective. Our satellites weigh now 200 kilograms and have an equal performance, if not higher performance, than traditional SAR satellites. And we update them over software, over the air. That unlocks an entire new level of economics and use cases for synthetic aperture radar. By now, we launched the first microsatellite in 2018. Then we doubled since that, basically every year. Now we have 72 satellites in orbit. That's the largest SAR constellation in the world. And part of this is owned and operated by ICEYE. If you have 72 satellites in orbit, it unlocks a new use case. You can move from strategic to tactical and operative use cases. Usually, when you wanted to understand how is a SAR image, what's happening on Earth, you task a SAR satellite. After 1 week, you get an image. And then maybe 2 days later, you have the analysis done. And then you understand what's happening on the situation. That's a strategic use case. But now we manage this in some cases by under 15 minutes. Under 15 minutes to task a satellite, get the picture down, analyze it, and hand it over to the use case wherever it's needed. Not for all use cases, but for many. The benchmark for us is at the moment 30 minutes. And as I said before, we are doubling. So we are considering SAR satellites a product. So we are developing it in product generations. By now we are at generation 4.5 with 25 times 25 centimeter resolution on Earth. We believe that we are planning to halve that again over the next years. And we are launching satellites non-stop. At the moment, our factories produce 1 satellite a week. We are planning to double that. And we are launching next year. We have, I think, 60 planned starts already through 2027. Who are our clients? Our clients are satellite missions. That means we sell entire constellation or individual satellites to sovereign nations. It's a turnkey solution. You can order a satellite from us. We hand it over once it is in space. We train the personnel so you can analyze the data that's coming out of that. We sell the satellite data in a more or less raw format. Basically, you could theoretically ask on our website to have a specific observation for a specific area of interest. And we sell solutions. Solutions are very dense data sets, especially relevant for disaster recovery, natural catastrophes, etc. And of course, since 2022, since Russia attacked the Ukraine, our defense and intelligence use cases make up the largest chunk of demand. That means, as we see through clouds, as we see tonight, we have a 24/7 observability out of the area of interest. And you can understand what's happening on your border without any compromise. We can detect changes on strategic sites. We can also detect changes in structure. So if a building was damaged or not. We monitor ports. And of course, we can monitor oceans. So no matter if there's a signal of the shadow fleet coming in or not, our satellites can see it. We can see if something is tracked behind. And these use cases are used on a daily basis at the moment from Europe, European states, and beyond. But also the same fleet supplies information for civilian use cases. When the hurricane in 2022 hit Florida, Hurricane Ian, within 24 hours we were able to provide a report that had like a 3 times 3 pixel resolution and was able to show what buildings were damaged. That means where does disaster recovery is needed mostly, and also how far we can faster process. With this information, you can process insurance claims much faster. later on in an ex-post or ex-event, after-event analysis by the United States, we figured out that we covered 97% of the area affected with a 30-centimeter error range. You remember the flood in the Ahrtal in 2021? The federal government analyzed that the failed disaster recovery afterwards was mainly due to a lack of situational awareness. We didn't know what was going on the ground. Now, like in 2026, the situational awareness is basically always possible, always on. And it's built in Europe. And that's, I think, the most important part of the story. It was started in Finland and now scaled production, manufacturing, research across Europe. We have production facilities in Germany. We're building them up right now in Valencia, in Greece, and in Finland. And we are anchoring like R&D in each of these countries. Since earlier this year, we have a joint venture with Rheinmetall here in Germany, producing more than 40 satellites to watch like the eastern flank of Europe. So the German state by now relies on ICEYE technology to secure the troops that are based in Lithuania in 2028 following. ICEYE aims to deliver the scale and the speed that Europe needs to become sovereign in space. So the key facts to remember, I believe, are 72 satellites. We scale the production through Europe, 1 satellite per week produced. And we are really ready to support Europe in space wherever we can. Thank you very much.
Thank you, Philip. Wow, amazing what comes from a technology that was first started 80 years ago. Our next speaker is a board member at OHB System AG, which is the veteran player in this group. They've been around for over 45 years. And OHB builds the platform that every satellite in this chain needs, the platform to ride on. So Christine is going to give us the bird's eye context of what they're seeing across the space value chain. Welcome, Christina, to the stage.
Hey, welcome everybody. Happy to be here. Happy to give you a special view on the space industry. So OHB is around for over 40 years. We are doing roughly everything which relates to space. So from launches over satellites up to analytics. And today I want to give you a sort of magical view, I would say, on space, the true origin of space. So what you see here is actually our home. And considering the humans on Earth, it's just a very short time we are able to really observe, to see the Earth and to understand it at full scale. So when we want to understand Earth, it's about climate, it's about ocean atmosphere, it's about ecosystems. And from space, suddenly all of that becomes connected. You no longer see any borders of countries or something like that. So this is a major part of space. It's not about leaving the Earth, it's about understanding the Earth. And here in Europe, we have a huge heritage, and we are really competitive in Earth observation. So we have building this over decades, and actually OHB has an exceptional heritage in Earth observation. So what you see here is an extract of satellites we were contributing to, constellations which we are building. And either it's related to security-related questions, it's related to environmental questions, weather, climate. All of those satellites are giving you the relevant data to understand actually the effects better. So we are continuously scanning the planet across all domains and at all times. So this is a sort of possibility to get the digital twin of the Earth, built in orbit. And behind those systems, there is even something more powerful. You will discover on the next page. So we don't observe the Earth just with our eyes. We are contributing to the entire electromagnetic spectrum. So we are building satellites from X-ray to visible to infrared up to microwaves. And each wavelength reveals something different you can understand, like temperature, like gases, like vegetation, like movement. And this is giving humanity multiple senses. It's not just sight we are contributing to. And because most important things happening on Earth are invisible to us as humans. So let me make this even a bit more concrete. I will now deep dive in several applications, Earth observation applications. We as OHB have heritage, flight heritage in. So what you see here is a radar example, Salupe Sara. Radar doesn't need sunlight. So it can see through clouds. It can see through darkness, which means we can observe Earth anytime and everywhere. Floods, infrastructures, movement, everything, under extreme conditions. When visibility ends, understanding begins. Now, compare this to optical systems we are also building. So this is a contribution of the platform NAOS. Optical systems which do see every detail. Extremely high resolution views for what is happening on ground. From infrastructure to environmental changes, down to security. And what comes next is even more fascinating, because we now deep dive even more. This is about hyperspectral. So this is sort of truly, truly powerful. What you see here is Bosporus. And hyperspectral images doesn't capture an image only. It captures the chemical signature of the surface. So it tells us what plants on Earth are stressed. It tells us what minerals are present. And it also discovers the state or the pollution that exists. So besides seeing the Earth, we can measure actually the health status of Earth. And this is like turning the planet into a living and measurable system. Now let's scale to the entire planet. The next example of our portfolio is MEOSAT. It's a newest generation of a weather satellite. It does measure most dynamic. It's a most dynamic system to measure weather on Earth, and this system has much more updates available than we ever had. It has a higher resolution. It has a better prediction. So the impact is everything of all the data are gained earlier, better, and we can save lives. So weather is not just information. It's a crucial factor to actually guarantee resilience. And now we come to a very sensitive region on Earth. It's a very sensitive region for all of us, we know that. It's the Arctic. The Arctic is one of the most fast-changing environments, regions of the planet. And it is also one of the hardest to observe. So no way to observe that without space technologies. And this Arctic weather satellites do actually have microwave instruments that allow us to measure temperature, to see the ice, the atmosphere, and actually what happens in Arctic doesn't stay there, of course, but the understanding on site helps us to define the relevant actions. Next example, Iride, a constellation from Italy. with amazing operational capabilities. High resolution, multispectral, again, faster decisions, better services, real-time application. So we are moving from observation to action. This infrastructure provides us the possibility to action. And then maybe one of the most dominant problems of our times, the carbon problem we do have. So together with ESA, we have actually developed this amazing contribution to help here. It's part of the Copernicus missions. It's the CO2M satellite. And this is, I believe, one of the most fascinating things which will fly very soon. Space is not about exploration only. It's about responsibility. And all the different views I have actually demonstrated here, the contributions we are having in our portfolio for Earth observation, help us to make a difference here. Because only with the view from the top, with the understanding, we can actually get to action. So I really thank you for your attention. This is one of the most fascinating times for space. Everybody's talking about industrialization, which is crucial. I will talk about that later as well. But I believe to remember the origin of space, where we want to understand human being, where we want to understand the Earth and our universe, is one of the major motivations we at our company have. And we are very happy to contribute to the future of space. Thank you.
It's not about leaving Earth, it's about understanding Earth. I had no idea there were all these different kinds of information to be gleaned. Well, radar tells you what's there, and with Constellar's thermal capabilities, it can tell you what it's doing, turning detection into understanding potential intent, which then can, of course, drive better decisions. Our next speaker is Max Gulde, CEO of Constellar. Oh, there you are. Welcome, Max, to the stage.
Thank you so much. Okay, so we've seen a lot of things already. And the truth is that even though we might sell every single data set as the silver bullet, it actually isn't. It's a combination of the data sets. Right, Philip? And we have a good speaker who's following me with Daniel, who will tell you a little bit about merging these data sets. But obviously, I also do the pitch and telling you why this data set needs to be part of the mix. So what are we? We are a satellite operator. But before I go through all of that, what we're doing and what we're not doing, let me tell you a little bit of a story. And this gives you a good idea of the significance of thermal data. This year is Ras Laffan in Qatar. It's one of the largest LNG terminals in the world. Between 20 and 25% of all LNG worldwide is stemming from that origin, and it's at the Strait of Hormuz. Right? You might have heard there are things going on in the Strait of Hormuz lately, and you might have also heard that as Europeans, we do not have access to US assets as of now. It has been blocked. Sometimes has been blocked for 48 hours, then has been unblocked, then has been blocked for 96 hours, then has been unblocked, then it's blocked for 2 weeks, has been unblocked, and now it's blocked indefinitely. So as much as I wish it would be different, we cannot really rely on non-European assets as of now. So let's dive a little bit into this. This is, as I said, a refinery, and we have different companies working there, right? And this is obviously an optical image. Now, what happened on the 2nd of March this year is that this refinery got hit by a Iranian drone, and on March the 3rd, it has been called out force majeure and has been apparently shut down. 1 day later, we took an image. This is a thermal image. So this is every single pixel is the temperature measurement, which means I'm showing you a false color map. That means that blue, in this case, means cooler colors. Red means warmer colors. You can immediately see that it's a nighttime image because the sea is warmer than the land. And you can also see right here that there's still a lot of activity going on despite the apparent shutdown. And there's a lot of activity going on here, right? And you have this thermal plume going on here, so showing that it doesn't really look like a shutdown. If you look at the market prices, however, they went through the roof. So now it was been hit again on the 16th of March, so about 2 weeks later, by another drone, and it was actually then shut down. And this is how it looks in a shutdown version, right? You actually do see that the whole red thing became more bluish, more greenish, which means the temperature has been reduced, the activity has been reduced, there's more flaring, and actually we do not see as well through clouds as you guys from my side, but we can see a little bit through clouds, right? Which you can see on this right-hand side, these kind of blue shadows. So what does it mean? It means that we can not only see what's there, we can also see the activity and validate this activity. And actually, these images I think are fine to show because they've also been published in the Wall Street Journal. To give you a bit of an overview, and maybe this could have been the first slide before going into Earth observation, what we're doing, you have different modalities in Earth observation, right? And the first modality, which is well known, is basically taking your mobile phone to space and taking the image. And this is what we call visual, and it gives you the categorization of objects, right? You bunch a couple of pixels together and you see, this is a tank, this is a refinery, this is a tree, this is an agriculture field, and so on and so forth. Philip has already pointed out, it doesn't really work at night, right? So about 10 years ago was the, let's say, onset of commercial SAR imagery, where you suddenly had the advantage of being able to look through clouds and you could look at night, right? Still gives you a snapshot, but basically this is bouncing off radio waves of the ground, gives you geometry information. And all of this is now, thanks to a lot of people, widely available. What's still not widely available is the missing layer, which we are bringing as Constellar, which is the activity layer. And here you can suddenly see behavior. So you're adding a category. What is it? It's a ship. Geometry and night vision and through cloud vision, so how big it is and is it moving at night with, hey, where has it been over the last 90 minutes? Is the engine on? Is it off? And where it's heading? Now, what I would like to do is give you a few practical examples of how this can be combined. Again, I'm not claiming this is a silver bullet, but I'll try to convince you that this is a very important data set to include into having a common operational picture. And I'm quite happy to announce that we are, by today, the most performant commercial infrared constellation on the globe, which also, to be quite honest, only took 2 satellites, not 72. Okay, thank you. This is 2 images north of Parik in Russia, so it's a Russian marine port. The left one is something we took ourselves. It's an optical, a visual image, right? And you see in the Arctic at night, it's kind of hard to see things. So it's pretty grayish. It looks like a cool summer night in northern Germany, where I'm from. The middle one you actually see is a SAR image, and you see all these little points popping up, right? All these little points. Those are ships, right? This is not from ISI. This is from Sentinel-1, so an ESA image, and this is publicly available. At the same time, we took an image in the thermal domain with one of our satellites. Again, it was night, and you suddenly see all of these lights, all of these lines popping up. And these lines are thermal traces of vehicles moving through the ocean. Because what happens if you move through the ocean, you're kind of mixing layers of different temperature, and until they unmix again or equilibrate in temperature, it takes some time. So you can see these thermal traces up to 90 minutes. So you don't need to take an image every 2 minutes. You can take an image every 60 minutes, every 90 minutes, and still have the full set of information. Let's dive into these images. And I can also show you how then the combination of different modalities can actually help you to get a complete set of information. Here we immediately saw there's a corridor which is made by an icebreaker, and we can even see where the icebreaker is moving simply from checking temperatures before it's moving through to after it has been moving through. The icebreaker we can identify very simply because it has its automated identification system turned on. It's basically sending information. This is me, this is why I'm moving every couple of minutes. There's another ship, however, which you see in the black circle, which is a dark Russian vessel. And we don't really know what that's doing. But it clearly doesn't want to be known what it's doing, so it has the AIS signal turned off. And the icebreaker is, in fact, clearing the route for the ship. Now, what happens next is that once you have this information, you know in which direction it's moving, and you know how fast it is, you can then task a high-resolution bird, be it from OHB, be it from ICE-Eye, to say, hey, please identify the ship. Something fishy is going on, pun not intended in this case. And the interesting thing is that, obviously, if you move above the surface, you are mixing different layers of water, but even if you're moving slightly below the surface, you still have a similar effect. And I'm not going to go into this more deeply. Again, pun not intended. So, another use case is Zaporizhzhia. We have a nuclear power plant. Again, false color map. Red means a lot of activity, a lot of heat. Blue means not so much heat. And if we zoom into the reactor area, we can now actually see for every single reactor, if the reactor is active, if it's not active, and we can even estimate the amount of energy which is produced simply by looking at the difference between the cooling water coming in and the cooling water coming out. And it's extremely hard to have a lot of energy produced and then to hide this amount of energy. So as soon as you're doing something which requires any amount of energy, we will very likely see it. And here, just to give you an impression how easy it is to spot that, this is the power plant in full operation. This is how it looks to us, and this is it in cold shutdown. Does it change the geometry? No, it doesn't. Does it look any different from the outside? No, not really. You might see a few more cars parked there, right? So it's a very good activity indicator, and we can even quantify that. And that's what we've done in China, Hangzhou Bay, sorry. So here we have two power plants where there's actually some information available, and we can see from the minuscule temperature difference in the thermal plume in the water from the cooling water, how much energy is actually produced. Now translate this into your mind, into other areas. This is a very obvious one, right? Who is also using a lot of energy? Data centers, right? So we've been tasked on a regular basis to look at data centers and their output. Who else is using a lot of energy? Well, any manufacturing industrial site. And if you know what is produced, is it a tank, is it a drone, is it something, I don't know, ammunition, then suddenly you have a good indication, an early warning system of things which might happen. Assuming you have a state which is suddenly increasing production of drones and ammunition, you have a good inkling of what this state is preparing for before you actually see the result. So it's not a post-mortem thing. Oh, crap, they attacked us. It's an early indication, an early warning for things to come. Right now, we've got about 2 satellites up, roughly, right? I'm a physicist, so I speak in rough numbers. We're entering series production, and I'm looking forward to the point where we'll be able to produce 1 satellite a week. It's not going to be next week, that's no secret. But we're already producing a next system. This is actually an image of Toulouse. This is what the capability is right now. And it's about 1,000 times higher resolved what the best public data is available for now. Obviously, the public data has been done for climate change, not so much for looking at tanks and stuff. And this is already what we're building for 2028, and that's going to be ready to launch, and I'm happy to say that this is on track. So if there's one message I would like you to go home with, not immediately, please stay, it's an amazing conference, right? But what you can take home with is that there are a lot of different data sets. We'll hear in a moment how these data sets can be combined. But one thing which is really important is to know earlier than someone else what's going to happen. And this capability can relatively easily be inferred on using thermal data. And very happy to present you Constellar as Europe's sovereign thermal data provider. Thank you so much.
Thank you, Max. If I remember correctly, last year's presentation, you were focused more on agricultural observation.
That is correct.
So in a year, the change in the geopolitical context has really changed how much leverage your technology has.
Okay, little secret, we're still doing 70% of our revenues in agriculture, and we also have 2 weeks more warning time in agriculture when it comes to yield and so on. Than here, but this is a very, very interesting field, and we obviously need to play in here too, because now it's about all our safety. I've been to Ukraine, not the only one who's been to Ukraine, a lot of you have, and I don't want to have this reality here, so let's make sure that we build a strong Europe.
Yes, thank you for everything you're doing. Thanks. So as Max was teasing, what do we do with all this data that we're gathering from space? That's where Live EO sits in the value chain, where all these moving parts can be synthesized into time-sensitive decisions. And Daniel Seidel will be sharing that with us.
Thank you.
Oh, I meant to give you the yes.
So you are a bit warmed up, right? You have seen thermal data, you have seen radar data. And I like to look back like 10 years because back then people said, and I think ICEYE, you have seen this on stage, it's impossible to put radar in such a small satellite. And Max, where are you? Are you still here? Last week I was in Sevilla at an ESA conference, and they told me just 3 years ago, they said it's impossible what Constellar wants to do, right? They actually want to replicate a satellite which had cost more than 10x the cost. It worked. They made it. And I think this is something we see over and over again. We have seen this in space in the last 10 years, and that's why we are super excited. We are still at the starting point. And I'm saying this in a longer context, right? When we started LiveVO, we looked into the forecasts for the market. And back then, the US Planet Labs, for example, they had raised a lot of capital to launch satellites. ICEYE was coming up, and we said, okay, let's not start with the satellites. Let's start with the AI. If you go back to 2017, right, AWS was the only cloud operator with significant market share. So that was a new thing, but also AI, right? It started with random forest. It was traditional machine learning. And we said, okay, geospatial data, very large data sets. So that's a domain we can really make a difference as LiveVO. So we see ourselves as a geospatial intelligence provider, and we want to be the best in that. What does it mean? The first thing is the ingestion layer, right? You see all these different modalities. They come in different formats, different resolutions, different time steps. And you need to master that and standardize this. So this is the first thing you have to master. Then starts the intelligence layer, right? That's where typically 60–70% of the resources go in. It's a really, really tough one, right? Also from training data for the physical world to the cloud problem and the accuracy. And then at the end, you have detections, but someone has to do something with that, right? So you need an interface layer that on the civil side can be an SAP system, a workforce management system. On the defense side, it's a CETAware, or it's a battlefield management system. It's a Delta, right, system in the Ukraine. And mastering this end-to-end with software is a challenge itself. That's why we tackled this. Today, we are roughly 160 employees, headquartered in Berlin, but operating globally. And we also have 99.8% European funding, which is, I think, also a success story, that you can raise these amounts for such a deep tech in Europe. So what do we actually do, right? What are our customer bases? And 2018, we already have seen that infrastructure, so railways, power lines, pipelines, are the backbone of our modern society. And like Warren Buffett says, right, energy, you always need energy, right? So it's a good market to bet on. And now if you see the reports of the last years, the spendings on infrastructure are increasing, not only because of the data centers, right? Also because we need more resilience on the energy side. The defense spending, this was always a big driver for space. And now also Europe is waking up and thinking big, right? And we need to build up sovereign capabilities. So with LiveVO, we actually launched 2 products on the utility side, right? Treeline and Surface Scout, where Surface Scout already as a product helps us in the governmental space. However, in the governmental space, it's a lot about capabilities. That's why we launched a separate unit called Section 4, purely focusing on the defense side. And now, as of today, you see we already have a global footprint. And we use radar data, we use optical data, we use thermal data, right? The customer don't care. They want to have a problem solved. But with this focus on infrastructure, we could build a market leader globally. We also just signed the first deal with the German Armed Forces, where we were really happy. It took a while, but now we have a multi-year contract with them, also to provide our AI capabilities. This is how it started. So everyone takes the train, right? So sometimes trains get cancelled because of trees. So back then in 2019, we already analyzed the entire grid of Deutsche Bahn regarding the storm risk, but with high precision, so on a single tree basis. Yeah? And the second customer was E.ON, right? And then you have seen the big map of all the customers globally. One thing we learned, which is super, super important also in a defense context, is this one. We are producing models in a digital world. We are shipping in software, but at the end, it needs to survive the reality in the real physical world. And that's a huge difference to other AI domains. And it's very often underestimated. This is the most important part. And through multiple years and millions of investments, we actually built up multiple capabilities. This year's, for example, 3D reconstruction we do, just with 2 images from 680 kilometers, 1 meter vertical accuracy, right? This is something you can do from space today. And you can imagine also in a defense context, this is very relevant. Now, going end to end, right, on the interface layer, we provide workforce management solutions. So really where people can plan the work. And this needs scale and precision, right? Because it has to be on a single tree level, but covering an entire continent. And now what we as an AI company, we are also a space company, an energy company, you can call us a chameleon company, we can change. But basically, you see, with all these customers, we have created a lot of ground truth and feedback for our AI. And I like to fly with a chopper to the Australian outback, but it's even better if the customers provide the feedback in your applications as an AI company. This is, for example, what you can see here. That's our Surface Scout application, where you have case management, right? But the users, they just get a notification, something happened here. And then they look into it. Here you see the black line is a pipeline which is underground, and there was a fire, not good. So they sent the crews there, and they took pictures on the site and reported, right? So they put in text and actually started a process as a utility. Another example here, where based on optical data, we identified there was a fence which was built up coming closer to the pipeline, right? And we do this, for thousands of kilometers on a weekly or bi-weekly cadence. But then they went there, took pictures, and put a lot of text and more information here. And then if you followed the trends in AI the last year, with all the big models and agentic coding, I couldn't be more excited about all this data and what we can build on top of this. So with all these products, we have built up what we call a virtual constellation, right? Still not operating satellites. And we counted, it was like 300 satellites we actually have connections to, which you see here. And then we have our customers, all the tasking, etc., right? So this is already very automated. However, I want to show you a practical example that even if there are so many satellites already up there, there is not enough capacity for specific problems. These are all images, so every single green rectangle here, we tasked for just one customer. So every single image costs more than $1,000 typically, right? Just in the summer season. And we connected to multiple high-resolution optical constellations to provide 3D data. And just to explain it, this is April, this is October. And with all the high-resolution optical satellites, from Airbus, even from the Turkish MOD, this was how they performed, like the white line. These were some scenarios we calculated. We wanted to hit this orange one, right? And you could see June, July, even having very sunny weather, they couldn't match our demand. And that's where we actually came up with vertically integrating hardware with our own Twin Spectre mission, which will be Germany's first constellation commercially operated, which can deliver sub-meter data, actually 35 centimeter, and one of the most performant in Europe. And I mentioned that ESA said what Max was doing with Constellar is impossible. They also think this one is challenging because like the satellites in the performance class we are in is typically like an Airbus Pléiades satellite had cost 300 million. We do this for like 10th to 20th of the cost 15 years later. Yeah? So they launched 15 years ago, which shows you how technology and the new space economy is changing the game also from a cost side. And with reduced cost, you can launch more and increase the capacity. So yeah, it's a big one, 500 kilogram mass on the multispectral side. We don't launch radar satellites because we think ISI is doing a great job there. You have a lot of capacity. Thermal, we also see a lot coming up. But here also as a size comparison, right? People talked about CubeSats the last years very often as somehow an angle of a new space. A CubeSat is like 10 by 10 by 10. Here you see just our camera is roughly like 1,000 CubeSats. And here's a simulated image of what we will achieve, right? So if you look up and there are no clouds, you could actually see if someone is sitting on the chair or not, right? Just from the resolution with 35 centimeter. And yeah, that will be very powerful. We focus also a lot on the 3D modeling side, which has a lot of elements. Because also on the defense side, right? You really want to like don't be in a situation where you plan something and then you realize, oh, I'm actually fully visible, right? There is a small mountain, a small slope over there, and they can see me. You want to understand also the vertical domain, the 3D domain, and if you are in contested airspace where you don't have drones, that's the only way to do it. Yeah, that's what we will provide with our Transpector constellation. And then, yeah, here you see like the camera model, just to get a feeling for the size. And at the end, we have heard this also in ICE's presentation, in Constella's presentation. I think we in Europe, right, we made the plan to become sovereign when it comes to tech. We have the companies and entrepreneurs and the investors backing this. So now it's just about the execution, right? And for us, it means not only having a sovereign satellite bus, right? We actually have German and mainly German suppliers. We now in our office have air-gapped GPUs, completely secret. They can actually go to a NATO secret level as IT infrastructure. We train the models, right? So also here's sovereignty, and we bring the integration. And I think with this we can get a strategic advantage, get more independent from the US. And I think what you should take away as the #1 thing is that we can get it done here in Europe. Thank you.
Thank you, Daniel. You packed a lot in there, but what I got was that the technology needs to survive contact with the physical world.
Exactly.
All right, bringing us full circle is our final speaker, Ezequiel Sanchez, Executive President of PLD Space, which is the second of the 2 front-runner launch companies you'll hear from today, and this time with more of a focus on what I think is going to be the commercial challenges we need to solve to make European launch a truly sovereign chain. Thank you. Welcome, Ezequiel, to the stage.
Okay, good afternoon, and thank you very much for the invitation to share with you where we are right now. This is not working. Okay, this is the first recorded image of Earth observation back in 1946. Since then, space has created a super huge industry, estimations of over or close to 2 trillion, but out of that industry, access to space is probably just 6% of that amount. But without that 6%, you don't have the other 94%. And that's probably one of the main constraints that we have when we look at our sovereignty, which is concern because most of the conflict are advancing at the pace of someone switching on or switching out a specific constellation and changing whether you have PNT, communications, and Earth observation. In that sense, in the last 20 years, what we see is that who controls the access to space has the full control of the value chain. You have plenty of any of the layers of the value chain, but there are very few having access to release a specific speed of deployment of any constellation. Many people wanting to deploy their constellations, but very few companies granting that access to space. And that's exactly the problem that we have in Europe. Over the last year, just one company got 165 launches. By the way, 75% of those launches for their internal consumption. And the other 25, half of that was for the Ministry of Defense, and the other half was subsidized by European companies which are offering the possibility to deploy infrastructure at all levels. So we are lacking possibilities to access space, and this is not something that it's a problem just for a specific country. It's a European problem at all levels. Somebody said that we got up from a nap, and I think that we were waking up from a nap, no? After what we have seen in the last 4 years. What we are doing is providing that access in order to have the sovereignty to launch our own constellations. Our value proposition is not over-engineering. It's just looking to our customers and exactly getting a not overpriced, reliable, and not over-engineered value proposition. Customers are not asking for 3D printed materials, neither composites at certain parts. What they want is just a service. And it's an industry that has been very much looking at their own capabilities instead of looking at what the customer was really demanding, probably because of the size of the challenge and the difficulty of accessing to space. What we provide, it's a vertical integrated model. We start with raw material and we end up with a full ownership of the launchpad, the testing facilities, the manufacturing facilities in order to provide what we call the make and buy. It's if you don't have possibility to know what's the cost and timings and requirements of every specific or every single part number, you are like giving the keys of your profitability to a third party. So that's why we're relying having this vertical integrated model and testing as much as we can. We were the first private company to launch a successful rocket in Europe. That was back in 2023. Since then, no one has ever done it. And we are planning in the second half of this year, our second vehicle to fly from Kourou, from French Guyana, from the CSG. We are on time to do so, and we expect to be the first company to do an orbit injection privately in Europe also. Our best asset is the team. It's a young team, 32 years old, the average age, and with 470 people of 23 different nationalities based in Spain. Competitive place to live and work and do both things quite good. But our ambition is huge. We started with, and we were quite criticized for that, for creating a suborbital flight in order to develop the brand. Our team and 70% of the technologies that we need for Miura 5. We are already working in Miura Next, which will have a cluster architecture that will provide us with the possibility to fly any type of payload to any orbit. Many of the things you have seen were impossible at the time. We faced thousands of no's from investors, institutions, media, talent, analysts, at all levels. Being a pioneer, I can assure you that it is neither cheap nor fast to do it. But despite that, none of them we feel are the last. We will deliver as we have always done, and we think that having the challenges in Europe, we are surrounded by not very good neighbors all around. So we have to defend ourselves and we have to invest and protect our technologies. There has been like some of the contributions that I very much appreciate from the previous speakers, that we think that we have super good technologies. We don't need funding, we need contracts. We need to really trust on new entrants and who are complementing what already exists in the industry and act as the key opportunity and behave the key. Well, this is not, they are not football fans. That's the team celebrating that the rocket was not there, no, and it was like a smoky. But that was 2 years ago, so we don't sit on that. If we can pass, I think there was another one, and this is. Okay, just showing which is like the current very brief video, just what was the early stage. This is 20,000 square meters factory to scale up production with very competitive costs, full operational model, and the vehicle completely developed at lightning speed because of having also the experience with Mira 1. Some of the technologies we didn't have, like the separation, and that we have been super testing there. And very welcome to have any conversation with you. Thank you.